All right, so far in Chapter 6, we've looked at quadrilaterals and polygons in general. We've looked at parallelograms, and we've looked at kites. So now what we're going to do is look at shapes that are children of these parent shapes. So all of the properties follow along these lines and are passed on to what we call these child shapes. So a parent and child is just one where the child inherits all the properties of the parent. So start with rhombi, just because we finished kites most recently. So a rhombus is just the combination of a parallelogram and a kite. And it's going to have the properties that those two had. So it's got, let's think about its basic properties from its parents. We know that a parallelogram has two pairs of opposite I can use a symbol for congruent. Opposite congruent parallel sides. Okay, now if we add in, move over to the kite. If we add in the kite's property, where we have two pairs of consecutive congruent sides, well, now we have opposite sides are congruent and consecutive sides are congruent. So the only thing that can mean is that all sides are congruent. So this isn't really a new property. It's just the combination of the two properties from the parent shapes. So if the opposite sides and the consecutive sides are the same, then all four sides are going to be congruent. So that's our first property of a rhombus. It also brings down this property where we have two pairs of parallel sides. So that one is inherited, but it is still important that it is a parallelogram. So what's next? So we talked about sides, they're all equal. Angles, we inherit the same property from the parallelogram. So kites had one pair of congruent angles. The parallelogram had two pairs of opposite congruent angles. Since this is like more specific than that one, right? All cases here include that case. Because if we have one pair of opposite congruent, two pair of opposite congruent is like more powerful. So we carry down that property. We have two pairs of congruent opposite angles. So our opposite angles are congruent, but they're not all the same as each other. Just like a parallelogram, we have some acute angles here and some obtuse angles here, but we know that those are the same. All right, so next thing, if you remember from a kite, we had this diagonal, the long diagonal, bisects the two angles at the top and bottom. So it bisected the two non-congruent angles. But now that we have a rhombus, if we do the diagonals, they each have that property of bisecting their corner angles. So we have a property that diagonals bisect both all angles, really. All of the corner angles are bisected by the diagonals. So that means each diagonal splits each of the corner angles into two congruent smaller angles. That's going to be important. There will be a lot of problems that ask us to do that. We saw some with kites where we needed to know that these two were congruent, the two that were formed by that diagonal. But now we can use that on all four corners. We also carry over the kite property of the diagonals are perpendicular. So that's one that we'll use quite a bit because we know that we get some right triangles that way. So all four of our triangles that we form are going to be, well, now they're actually four congruent right triangles. But we'll be able to solve for any kind of missing information using Pythagorean theorem because we have right triangles. Let's see. I think that's all our properties. So we also I guess we're writing repeated properties too. So diagonals are going to bisect each other. and that was a property from parallelograms. So there aren't really new properties here because they're all a combination of the parent shapes. But I guess the ones that feel the most new are going to be all sides are congruent, because that's a kind of combination of those two properties. And then the diagonals bisecting both corner angles is kind of new to this shape, because with a kite, we only bisected one of them. But everything else here is just a carryover from the parent shapes. So these are all repeat properties. The two that are really new and kind of only show up once we get to a rhombus are these two. All right, so those are our properties. Let's look at how we can do some problems with this information. Rhombi. All right. So rhombus, we have a rhombus right here, and we have UV is equal to 8. That tells us that all four sides are equal to 8 because it says the shape is a rhombus. That's given. So this is 8, 8, 8, 8. And it says WX is 5. So that means, since the diagonals bisect each other, XU is also 5. The only missing piece of information is TX and XV, and since these are right triangles due to the perpendicular diagonals, we can use Pythagorean theorem and do square root of 8 squared minus 5 squared, which would be square root of 39. 39, yeah. 39 is 3 times 13, so that's not simplified. We can't simplify it. So now we have all our measures. I'm not going to write them in the blank because it's such a small space, but we get the idea of how we can find everything, right? The next one, we have BC is 28, and BD, the diagonal, is 32. It's hard to write that clearly, so I'm going to go ahead and break that down and make it 16 and 16. And that lets us find our missing piece, because we know this is 28, we know this is 28, we know this is 28. All we're missing is EF and FC, which are congruent, and we can find them by doing 28 squared minus 16 squared. That's terrible. I don't want to square 28, but I guess I make you guys do it, so sure, why not? So 28 squared is going to be 28 times 28. So we have 4, carry a 6 there. That's 16 plus 6 is 22. And then we have a 0, and we have 2 times 28 is 56. And my pen's getting really slow for some reason. So it looks like we should have 784, and we're going to subtract 16 squared. I feel, isn't 16 squared 256? 16, that's 6, 3, 9, 160, 256. Okay, good. 256. So we get square root of 528. Whew. 528 looks right. Can we simplify that? I have no idea. The digits add up to 5, 7, 15, so I know I can divide by 3. So that would be 3 and 176. 176, I can see it's even, so that's divisible by 88. Oh good, that has some, we can simplify, there's a 4 in there. So that's 4 and 22, which is 2 and 11. Great, so we found a pair of 2's and another pair of 2's. So we can simplify this as 4 times the square root of what's left over, just 11 and 3, so 4 square root of 33. Well, it's not pretty, but I guess we got there. But I'm sure it would be nice to have a calculator for things like that, huh? Okay, So now we have all of our information for that one. So those are the kind of problems you're going to see. And remember, since we've inherited all of the properties from a kite and a parallelogram, you need to know the information that they give us as well. So I'm going to go back to our notes page, because we're going to do in this video rhombi, rectangles, and squares. So let's go down a different path. So we talked about rhombi, which were a combination of parallelograms and kites. But now let's follow down just the parallelogram family to talk about rectangles. So rectangles, their sides, we have the exact same property as a parallelogram. So we have two pairs of opposite parallel congruent sides. No different than a parallelogram. We have, for angles, we still have the property that opposite angles are going, oh, I guess with rhombus I should have mentioned as well, we still have the property that consecutive angles are supplementary. So I missed out on that one because that was one of our parent properties, is that consecutive angles add up to 180. With rectangles, we still have our angle properties from the parent. We know that opposite angles are congruent, and we know that consecutive angles are supplementary. But we also now have made everything a right angle. So that means instead of those two separate properties about angles, we can simply say all angles are 90 degrees. So yeah, or we say all angles are congruent, either way. So that one is kind of a newish property, right? It's not directly inherited, it's kind of a combination of the fact that we have made the sides perpendicular with the fact that we knew the stuff about angles of parallelograms. Okay, so what else do we have? We have the same properties about diagonals. So diagonals, just like on a parallelogram, diagonals bisect each other. They do not, however, bisect the corner angles. So that was a property as we came down this right side of the family tree. Rectangles will not have two equal angles in the corner. Sometimes we forget where the property lives, and bisected corners goes down the right side. Okay, what's next with rectangles then? Diagonals bisect each other. Diagonals are also congruent. So think about splitting, just like I did here, this into two right triangles. We have SAS congruence between them because we have these sides equal because it's a parallelogram, these sides equal because it's a parallelogram, and our corner angle between those sides is going to be 90 degrees for both triangles. That means these are two congruent triangles, meaning if I draw the other way, it's also congruent, SAS. It has the same side angle side setup. So the two diagonals have to be equal in length, so they're congruent. So that is kind of a new thing we get with rectangles. I think that's all we need to talk about with rectangles. So everything else should be just the inherited properties. The really important ones are the 90-degree angles and the congruent diagonals, so equal length. So that means when we draw both diagonals, what we end up with is 4 equal pieces. So all of these 4 half diagonals are all exactly the same. Okay, so let's move on and look at problems about rectangles. So rectangles, we've got if UZ equals x plus 21, so that's part of a diagonal, and ZS equals 3x minus 15, that's part of a diagonal. And as we just saw, all 4 parts of the diagonals are the same. So I can set those two equal and do 3x minus 15 equals x plus 21. Move that around, I get 2x equals 36, so x is 18. It says find US, so make sure we don't stop too soon and we plug that back in. US is the full length of that diagonal. So it's going to be these two together, but I'm just going to plug in here and say this one is 39. This one's also 39 then, so US equals double that, or 78, whatever units we have here. So that's our property where we know all four of those now are the same because the diagonals bisect each other and they're equal in length. All right, so next we have RZ is that, ZS is that. Again, we know those are the same because it's a rectangle. So we set those equal, solve it, same kind of stuff. Let's go down to one about angles. So it says measure of angle SUT, so that's here, is going to be equal to 3x plus 6, and RUS here is going to be 5x minus 4. Well, those two form this corner of the rectangle, so they must add up to 90 degrees. They're complementary. So if I add them, I get 8x plus 2, and we're going to set that equal to 90 degrees. So 8x equals 88, x is 11, but again, they want us to plug something in. They say find SUT. We can find that SUT is 11 times 3, 33 plus 6, so 39 degrees. And just to point out, they didn't have to say solve for SUT, because we now know that SUT, RTU, USR, and TRS are all that same measurement. So we end up with 4 39-degree angles, and then 4 51-degree angles, which is the other complementary piece of each one. So really I would have expected this problem, instead of said find measure of angle SUT, it could have said find USR up here, and relied on us knowing those are alternate interior angles, and so they're the same. Okay, so that's angle problems. Rectangles are pretty straightforward. I don't know. So the graph a rectangle, determining from coordinates if it's a rectangle. So you're going to do similar to what we did for proving parallelograms, but then there's one extra step. So slope formula, we needed the slope of BG. So the slope of BG is going to be, so we go plus 1y and plus 2x, so that's going to be a half. And then the opposite side from that, HL, the slope of HL, is going to be, we go minus 1 on y and minus 2 on x, so that's also a half, negative 1 over negative 2. So those two are parallel. Then we do GH and LB, so slope of GH is, we go minus 6y and plus 3x. So that's a slope of negative 2. And then our last slope for LB is, we go in y, we go plus 6, and x we go minus 3. Plus 6 and minus 3 gives us negative 2 again. So this is enough to prove that it's a parallelogram. Now the one extra step that we need to prove whether it's a rectangle is that these are perpendicular. So we know parallelogram has this parallel to this and this parallel to this. But we also, to make it a rectangle, need this corner to be a right angle, meaning the two slopes we found need to be perpendicular to each other. And we can see that 1/2 and negative 2 are opposite reciprocals, so yes, this is a rectangle. They also have you doing this with the distance formula, so that's where we're finding the lengths of the sides to confirm that it's a parallelogram. And then again, we need the sides to be perpendicular to know that it is a rectangle. Now, if I were given the choice of which method to use, I would certainly pick the slope method, because we already need the slopes for that last step. So if we use distance formula, we're going to be calculating all those distances, but then we also have to go back and calculate that the slopes are perpendicular. So this one is certainly going to be our easiest method for figuring this one out. Okay, so that about does it for rectangles, and then we'll finish up today's notes with squares. So squares, I mean, there's nothing new about squares. There's really no notes to take because they're just a byproduct of their two parent shapes. They have all of our rectangle properties and all of our rhombus properties. So everything from parallelograms, kites, flows all the way down to squares. So let's just look at some practice problems instead of worrying about notes and see how we can use those properties. So we start with squares at number 9 here on page 39. And we know that one property that all of these shapes have is that these are all equal. That's because it's a rhombus. We also know that the diagonals are equal. So we know that VT is going to be the square root of 15 squared plus 15 squared, or we can use the shortcut since those are equal, it's just 15 times square root of 2, because we do square root of 15 squared plus 15 squared, so we end up with 2 times 15 squared, and that's a pair of 15, so they just come out. So anytime we're doing Pythagorean theorem with 2 equal leg lengths, the hypotenuse is just going to be that length times the square root of 2. So let's see, that gives us VU is 15, SU is going to be that 15 square root of 2 that we just found, because that's a diagonal. TV is the other diagonal. It's equal because it's a rectangle, so the diagonals are equal in length. And SW is half of that, so it would be 15 root 2 over 2. So simple enough. Just as like a thing to have in your head is square root of 2 is probably the most useful one to kind of, if not memorize, know roughly how much it is. So square root of 2 is 1.414. I said you should know it, and then I totally forgot it. So square root of 2 is about 1.414, and it's nice because it's just repeating numbers, so it's kind of easy to remember. And then square root of 2 over 2 is also useful, and that one is 0.707. It's just half of that one, right? So half of 14 is 7, half of 14 is 7. So the repeating numbers, to me, make that one a fairly easy one to remember, and it is pretty useful to be able to roughly estimate square root of 2 or square root of 2 over 2 throughout all of the math that you're going to do. All right, so next one is more stuff with side lengths and diagonals. Let's go down to 11 where we're looking at angles. We have EFG. Well, this has all the rectangle properties, so that's 90 degrees. GDH. So there's nothing labeled there. But remember that we have the property that GDE is a right angle and that DF is an angle bisector, because we get that from the rhombus. So we know that these are congruent, so they must each be 45 degrees. And then FEG is going to be 45 as well, and DHG, since that's a central angle of a rhombus, is going to be 90. So pretty easy for that one. And then here we know, with nothing else labeled, we know that this 6x minus 21 has to be 45 degrees, and we can solve with that. So yeah, here we have just some matching of what properties. The key thing to remember there for what properties a thing has is that those properties all flow down from the parent. So if you were to say on that a parallelogram had a certain property, all of its children have to have that as well. So if a parallelogram has a property, so does a rectangle, rhombus, and square, because they're all children of the parallelogram. Whereas if a kite has a property, only the rhombus and square have to share that property. This side of the family doesn't, because they're not below the kite. They're not following this flow down that flow chart. Okay, so that's notes on kind of the rest of this branch of the family. We talked about kites and parallelograms separately, and this finished out the rest of those children shapes.